Question number 5 asks us to show that neither the ratio test nor the nth root test can be used to determine whether or not the series 1 over n to the power p converges or diverges. Okay, so what we're going to do first is we'll maybe do the ratio test. So the ratio test is the limit as n approaches infinity of an plus 1 over an, and the absolute value of that must be less than 1. Essentially checking the ratio of the terms at the nth term of the sequence, so down when n is really big, and seeing if it behaves like a geometric series. Okay, so we're going to set this up. So we're going to do the limit as n approaches infinity, and in the numerator, I'm going to have 1 over n to the power p, and n plus 1 to the power p. It's going to be n plus 1 to the power of p over 1 over n to the power of p. Okay, so we're going to rearrange that. Limit n approaches infinity, n to the power p over n plus 1 to the power p. Okay, and because we can really ignore everything other than the n to the power, the highest power, or n to the power p in the numerator and n to the power p in the denominator, the ratio of the coefficients is exactly the same. So we're going to end up with this is equal to 1. Okay, when it's equal to 1, it's inconclusive. Okay, so the ratio test is inconclusive. Okay, so then we can move to the nth term test. The nth term test states this. We're going to look at the limit as n approaches infinity of the nth root of an. Okay, and we're going to see if that is either equal to 0, equal to 1, less than 1, or greater than 1. Okay, so if it's equal to 1, it's inconclusive. If it is less than 1, it's convergent. Equal to 1, inconclusive. And greater than 1, divergent. Okay, so this would be our nth term test. So we'll set this up. We're going to put this in. We're going to say the limit as n approaches infinity, the nth root of the sequence was 1 n to the 1 over n to the p. Okay, in this case here, when we simplify this, we know that the nth root of n is going to be equal to 1. So I'm going to set this up. So the nth root of n, okay, so we're going to separate this out to the nth root of the 1 over n, and then outside of that, we're going to put the p, because we can do this using the property of powers. So we know that the inside of this, the nth root of n, or even 1 over n, so the nth root of n in the denominator is equal to 1. And so we can come to the conclusion that this is equal to 1, okay, to the power of p. Well, that's equal to 1. Okay, if it's equal to 1, this test is inconclusive. So we have an inconclusive situation in both cases. So neither the ratio test nor the nth root test seems to be able to determine that whether this is convergent or divergent.